All right, welcome to week 4. What are we going to cover this week? I'm going to try to finish off what my voice didn't allow me to do last week. That's for starters. I'm also going to cover how to resolve many relationships when you're actually going to the point where you're doing the physical diagramming. I am going to talk about data types. I'm going to talk about a few other things. All right. Specifically, I'm going to talk about resolving many-to-many relationships. I'm going to cover keys, whether natural versus synthetic. I'm going to talk about the design process of how to actually get to the point where you're doing physical designs. And I'm going to talk about data types, not specifically what each data type is good for, but how to pick the data types for your database. All right. By now, this should look somewhat familiar, right? Many-to-many. An order has many products, a product has many orders. That's nothing too far out of the ordinary. However, logic, when you're doing a conceptual, this is okay. When you're doing a logical, that might be okay. When you get to the point where you're doing a physical, that's not so cool. What I'm going to do is I'm going to show you guys using logical diagrams because I don't want to muddy the waters with data types. So I just want to explain how you'd resolve the situation. Now, using a logical diagram, this is how you'd resolve it. And I've added an extra field in here just for giggles. But let's say an order is made up of an ID and a date. A product has an ID and a name. Where before you had a line that just says order has products and products has orders, you'd create a table in the middle, and this is what they essentially call an associative entity. There we go. Whew. I was drawing a blank for a second. It's an associative entity. In other words, its primary key is made out of the primary keys from two other tables, and it has one last little bit in here, which in this case is the quantity. I'm just going to go shut the door, because if I said anything like last week, it's going to get loud in about 10 minutes. Do you mind shutting the door for me at the back? Somebody? Anybody? So when you actually get to the point where you're talking about many-to-many, the minimum way of handling this is like this. It's not ideal, and later on I'm actually going to, after I talk about synthetic keys, I'll describe how you should have fixed, how this should be fixed, because this does have some really big limits. What happens if, for example, to give you guys something to think about for a minute, we have products, but the products have different options. For example, black t-shirts. You're ordering something from a t-shirt shop, and depending how they organize things, the product ID could stay the same because it's a black t-shirt, but then there might be an option of a size. Well, the way this is designed right now, could you order 2 different black t-shirts? No. Because a given order can only ever have one matching product. So you could have a black t-shirt, a gray t-shirt, and a red t-shirt, but you can't have a large black and a medium black because it's not designed to handle it. Of course, obviously, you could just create more and more products instead of having options for the product. But you end up with, if you need extra stuff in here, like notes and whatever, it starts getting really dirty fast because you have limits of how many times you can add a given thing to an order. And that's not very good because, well, sometimes you need to add the same thing to an order more than once. For example, where I work, a reseller will often buy 2 copies of the same package of software. Why? Because they're selling 2 packages to different people. We're selling it to him. So that's saying that we could not add 2 copies of SignLab print and cut to the order as 2 separate line items if it was built like this. And then we have to add them as separate line items because of some of the stuff we track. So this has limitations. And when I talk about synthetic keys, I'll be describing how you could fix this. All right, synthetic versus natural keys. It's a really important concept when you're dealing with database design. I put up a couple of pieces of terminology on here. A composite key, it's a key that's made up of 2 or more attributes. If you remember the previous slide, the table in the middle had a compound primary key. because it had two columns as part of the primary key. A natural key. A natural key is it's a key that's a form of attributes that exist in the real world, such as social security numbers, or maybe a phone number or an email address. Those could be natural keys. They exist out in the natural world. A synthetic key, which is also known as a surrogate key. So when you go looking online for different things, sometimes they'll refer to it as synthetic keys, sometimes they'll call it a surrogate key. They mean the exact same thing. A synthetic key or a surrogate key is a key that has no business meaning. In other words, it's an identifier for a piece of information in your database that has zero meaning outside of that database. Its only purpose in life is to make the database happy. For example, if you talk about a synthetic key and you talk about products, it's product 55. Does that mean anything to anyone what product 55 would be? No, you tell them it's a black t-shirt. They're happy. But product 55 means nothing. So it has no business meaning other than help identify pieces of data in the database. Primary key, by now we should know what a primary key is. It's the key that's used to uniquely identify a given entity type. In other words, each of you have a student number, therefore that's your primary key as far as the college is concerned. Each of you are an entity type of student, therefore the primary key is student number. A foreign key, one or more attributes in an entity type that represents a key, whether it's primary or secondary from another entity type. In other words, there's courses, there's classes, and students. A class is made out of a course and a group of students. Therefore, in the class, the foreign key would be a student number or student ID. And maybe the course code would be the other foreign key. Those are designed to identify things on the outside. All right. All right. Lots of text on this. The slideshow is on Blackboard. And somebody, I don't know your name. I don't know your name or your face, but you identified a typo. Thank you. I appreciated that. When you talk about natural keys, you'll have a lot of database designers, especially the old school guys that have been, let's go with out of the loop for a while, will tend to argue towards natural keys because they're things that exist in the real world. Therefore, it's a good way to uniquely identify data. There's problems with natural keys. And as you can see the list here, it's a really long list of issues. So if ever you get into a discussion with, let's say you just got hired on somewhere and they've got an old school database designer who insists on using natural keys, you can pull up this slide and say, no, you're wrong. Okay, there's 10 cons against using natural keys. Con number 1, the primary key size. Surrogate keys, also known as synthetic keys, don't have problems with the index size because usually they're a single column of an integer type. Like it's a data, it's a number, usually an integer, and integers don't take up a lot of room. It's about like as the slide says, it's about as small a piece of data as you can get to uniquely identify something. Now imagine if you used somebody's name as the primary key instead. And depending on where you're from, your name can be pretty damn big. Yeah, Puerto Rico. Yeah, most of the Hispanic countries have really interesting names. Like I said once, I had a student that I swear to God had 10 different names and he answered to all of them. Apparently in Puerto Rico, it's traditional that you tack on the father's or the mother's name to your name. And then you give your kid your name on top of your father's name. You know, Isaac, son of Isaac? Well, in their case, it's Manuel Federico, blah, 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 until they get to the guy's last name. At least that's how his family did. It was ridiculous. It was hilarious. Now imagine you have to index all those names as part of the primary key. That's going to suck. Because it's just so damn big. It's going to take up tons of room. And it's also going to make it difficult to actually do your queries and stuff. The foreign key size. See con number 1. Now imagine we're using Eduardo's long name. That means we've got to copy that long name to every time it's referred somewhere else. That name needs to be copied with it. That sucks. So that means your index, instead of being indexing a 4-bit integer or even an 8-bit integer, you're indexing a 50-byte character, right? So 8 bits in a byte times 50 as opposed to 8 bits. Con number 2, aesthetics. All right. Identifying a record with just a number as opposed to identifying a number with a mismatch of multiple columns. Aesthetically, and it's just really an aesthetic thing, a single number is a lot prettier than a series of numbers and letters mixed, jumbled together to uniquely identify stuff. Cons 4 and 5, optionality and applicability. Surrogate keys don't have problems with people or things not wanting to provide data. For example, how many of you filled out a questionnaire somewhere along the way or a pamphlet and not put your phone number down because you don't want to receive any phone calls? Okay? A couple of us, right, have avoided it. Or it says, provide your email address. No. You can't have my email address. Well, what happens if that particular site uses your email address as your primary key? Well, guess what happens? You're not going into the system. If you make the email optional and you use a surrogate key, the surrogate key takes care of uniquely identifying your record. So who cares if your name is Joe Bob? Because that's what you put in everywhere. It doesn't care because it can track records on its own without needing something external to identify it. Unique. I can guarantee they're going to be 100% unique. Why? Because they're numeric and they count 1, 2, 3, 4, 5. As opposed to if you used a natural key. Did you know in Ottawa there's 12 Daniel Goudreaus? Well, there, at least last time I checked the phone book when I still got a paper phone book, there was 12 of us in Ottawa. And actually one has the same middle name as me. What are the odds? You know, apparently pretty good. So it's apparently the Goudreaus are very original. And none of them are related to me. Just saying. So numbers are good because it's uniqueness. Now with Hispanic names, their names are so long, there's a good chance it's going to be unique no matter which way you cut it. Unless their name is Pablo, then that's not unique. And you also get some of that problem with using people's names as uniqueness when you start throwing in Asian names into the mix. Because, you know, even though it's not written the same way in the moon runes, it's written the same in English. It's not unique. Privacy. Do you care if your ID number 55? Do you care if the fact that your ID number 55 leaks out into the world? But all they have is ID number 55. They don't have your name. They don't have your address. They just have an ID number. Synthetic keys don't care because there's no privacy issues with them. What happens if your primary key is your name? There's problems. Accidental denormalization. You can't accidentally denormalize an integer. Why? Because it's an integer. What happens if suddenly the business need comes in that you have to track a person's first and last name separately? Suddenly now you could denormalize, you're going to end up breaking the data apart and you might end up breaking and denormalizing your data in the process. Or you might have the other way around where the primary key was first name field, last name field combined. Now some sharpshooter somewhere decides, you know what we're going to do? We're going to combine it into a single name field. Like you could be denormalizing data and breaking it that way. Cascading updates. Surrogate keys don't change. Your ID number 55. So let's say we're using a person's name as their primary key. And I'll pick on the women for this one. You got married. And you can't decide what to do with your last name. Are you going to keep it the same? Are you going to do the hyphenation? Or are you going to change it to your spouse's last name? And it applies to the guys too. You know, works for no matter which way. That example works for everyone. But what happens is if you're using the person's name as your primary key, suddenly you get a cascade update all the records. Person updated, then their address information is updated, then their orders are updated, and everything else is updated because you're using their name as a primary key. So if you're using things that can change as a primary key, it's not a good idea because you are forced to update the data everywhere. And I've had students in the past say, well, what if you use their SIN number? Anybody here suffer from identity theft yet? Did you know when that happens, what you have to do, one of the first things you have to go do is get a new SIN number. And guess what just happened? Everybody tracks you by SIN number. You're no longer, you got to go, they got to update all their records. Canada Revenue loves it when you change your SIN number. By love it, I mean they don't. One of my neighbors had to get their SIN number changed, and it took 3 years for Canada Revenue to finish fixing it. Because he had to go update all his old tax returns to match. And you can imagine how well that's running on those old COBOL systems and how long it takes to go update SIN numbers for 10 years worth of tax returns for each person that gets their shit stolen. All right. Con number 10, varchar join speeds. Character join speeds apply to varchar join speeds. Usually, when you're using synthetic keys, you're going to use integers. 1 is equal to 1. 12 is equal to 12. That's easy. Is Daniel Goudreau equal to Daniel Boudreau? No. But it's actually got to compare every single character. Therefore, it's actually got to parse every single string if you're using a name. Therefore, using character fields as primary keys sucks because you're actually slowing down your queries. The comparison operators are slow. The joins are going to be slower because the comparisons are slower. Obviously, comparing two numbers as opposed to comparing two strings, there's performance gains. Now, there's always going to be somebody that's going to argue about the disadvantages of using synthetic keys. The first one they complain about is it's hard to get the next value. Bullshit. I'll say the uncensored, what's not on the slide. Pretty much every database server supports auto-incrementing. Oracle's the one that makes it the hardest. And how long does it take to figure that out in Oracle? About 15 seconds. MySQL has an integer field that has a property called auto-increment. Postgres has something called serial, or big serial. Microsoft SQL Server has identity. What do these things do? They generate a sequence of numbers. You define your field as that data type, and the numbering takes care of itself. Oracle makes it a little harder. In Oracle, you create a sequence, then you set the next value to the next value of the sequence. It's an extra step. That's like everything in Oracle. It's always an extra step. Users don't understand them. They don't understand synthetic keys. Who cares? Really, should your user be referring to product number 55? Really? Are you going to trust them to actually know what those numbers mean? Oh, we're dealing with customer 3,255 today. Oh, that's John. No, we don't know who that is. Who cares? It's not a good argument. It's a pointless argument. Extra joins. Sometimes you use synthetic keys, you have to do an extra join. Usually you write your code. So you have to write an extra join in one piece of code once. Woohoo. It's not a good argument. Extra indexes. That one is valid. That one is one you can argue. Because what happens is if you're using a natural key, such as a person's name, as your primary key, you have the person's name as the index, period. With a synthetic key, you always have n+1 indexes. So, yes, your primary key is a synthetic key. There's an index on that. Then you index the person's name. How many indexes do you now have? 1 + 1 is 2. Whereas if you're using the person's name as your primary key, you'd have 1 index. Okay, for example, let's just say you're using a natural key such as a SIN number. You index the SIN number. How many indexes do you have now? Okay, let's just say instead of using the SIN number, you're using a synthetic key or surrogate key. That means that it's the primary key. The primary key always creates an index. But then you also index the SIN number because you want to search on it quickly. So how many indexes does that give you? 2. Synthetic keys force you to create a second index. Is that a valid reason to not use them? Not really, because the primary keys are you're indexing numbers. And it uses what's called a B-tree index. I cover indexes next week. But it uses what they call a binary tree, a B-tree index. B-tree indexes are insanely fast. They don't take up a lot of room compared to other index types. So it's the only one that has a valid argument against synthetic keys. So does that mean you should use the synthetic keys? Yes. So when you first start designing, as you did the logical where you didn't have synthetic keys yet, you just had, SIN number, product name, that kind of stuff. When you're actually going down to doing the physical design, start using synthetic keys. It has a lot of advantages. And the one drawback isn't really a drawback, because it's faster to join across numbers anyway, so the little bit of room this is taking up on your disk, realistic. There once was a time where this was important. Now, anybody in here other than me over the age of 35? Just a couple of us, maybe? One? None? Nobody over 35? Okay. Those of us over 35 probably remember computers with, 10 megabyte hard drives. 10 megabyte hard drives were great. They were huge back in the day. My camera takes bigger pictures than that. Not my phone, but my camera at home takes bigger pictures than that. Can you imagine storing an entire database in the space that one picture takes? Back then, you used to care because that index could be occupying 100K of space, even 10K of space. 10K is still occupying, 1% of the drive. 0.1% of the drive. So then you have 0.1% times 10 tables. Now you're occupying 1% of the drive just for indexes. That doesn't include the rest of the data that you're storing and the database and blah, blah, blah. But then again, let's turn around to the other argument. The natural key was text. So whereas the index could be 10K for a synthetic key, it might be 25K for the text field. But because the synthetic key occupied both, you're now occupying 35K. Which that's why people used to argue this a lot against this nowadays. Who's got a 120 gig hard drive in their laptop? Anybody in here got a drive that small? Hey? Well, yeah. Okay, it's a tablet. I said laptop. Anybody a 256 gig? That's what I've got in mine. Right? Well, I got 256 and a 500. I got two drives. But 256, right? Space is not an issue anymore. Like, honestly, it's not an issue. The database at work right now is occupying, last time I checked the disk space on it, it's 7 gigs of disk space. Do you think I care about 100K when I'm talking about gigs? Yes, not a good argument anymore. All right. Any questions about the advantages of synthetic keys as opposed to the natural keys? There is a place for natural keys in the world. It's just such a tiny niche little thing that, I've been trying to come up with one for the last 10 minutes. I'm sure somebody out there, a data processing professional, would come up with a good argument of using a natural key. There are some cases, especially with company, like, it's kind of odd, right? Because if you look at accounting systems, often the primary keys are invoice numbers. But the catch is that those invoice numbers are generated anyways. One of the few places where using a phone, say for example, a phone number, Bell, your phone number is going to be used as a primary key because Bell tracks those phone numbers uniquely. Well, they used to. Nowadays, they've had given up the monopoly on the phone numbers. But there is a registry of phone numbers out there, and they're probably using the phone number as the primary key. Because it makes sense. It's a number. Especially if you store it unformatted, it's fairly quick. Even though you can store it in a text field. Numbers in a text field is still faster than letters and numbers in a text field. Other than that, I think that's pretty much the only use I could think of it. I'd never use a SIN number as a primary key. I'd never use somebody's name as a primary key. Why would you use somebody's email address? How many of you have had more than one email address in your life? How many of you have had to change it because of spam or stalker? Take your pick. This applies to boys and girls, by the way. That stalker comment. Or it's been compromised because you had a Yahoo account, right? So there's all kinds of reasons why you change your email address. Was that a valid primary key if your email address changes over time? No. Actually, how many of you have actually been with Bell long enough that you've gone through the Simpatico days where you had a Simpatico address and suddenly became a Bell address? Although they still respect the Simpatico address, but realistically, you now have a Bell address. And, you know, you don't use that as a natural key. So there's very few reasons to use a natural key anymore. There once was a time. Nowadays, not so much. All right, now I'm going to talk about the design process. Man, my throat's still going on me. A week and a half later. Okay, the design process. The design process is iterative. How many of you have written code? Actually, I used that like last week and got it to work on the first try. A code that had more than, 100 lines. And worked on the first try. It worked, but it didn't do what you wanted it to do. Exactly. But normally how you develop applications and code is you write a little bit of code, you test it, see if it works. You add a little bit more code, you test, make sure that works. And it's a design and test process. Database design is the same way. It's an iterative process. There is no perfect design. There's no such thing as a perfect database. When you reach for perfection, it's going to cause problems. Because you can design till the cows come home. And then you have this giant unwieldy database that makes no sense except to you. Why? Because you decided that you should represent every city in the country in its own table. You got a table with just cities. Who the hell stores all the city names? That's crazy. And so it's made up of 4 steps plus an end of process review. Step 1, identification. Depending on the source of data, 2 common paths are available. One is a recreation / reverse engineering. Someone gives you a stack of paper and say, this is everything we know about our company. Here's an invoice, here's an order, here's a statement, here's a purchase order. This is what we know about our data. Here's an employment record. Here's what we know about our employees. Go to town. That really sucks. I hate that part of it. It's painful because you know you're going to miss something, guaranteed. Path number 2, clean room implementation. Anybody want to take a guess what that means? Anybody want to take a guess what a clean room implementation means? No? Holy cow. Crickets. I need to break out the cricket sound effects. Clean room implementation means somebody went on a vision quest. Came back and said, we need to make this. Go to it. You have no idea what they want. You have no idea what the data requirements are. You have no idea what the data looks like. You have no information. You're working in a clean room. There's nothing in the room but an idea. And then you got to build on this idea. However, these 2 paths have a couple of common steps. You have to identify all the possible gross data objects. For example, users, computers, customers, orders, things. Students, classes, classrooms, buildings, courses, programs. Those are all big things. And then you list the objects and categorize them. So you break out the objects into individual pieces and you see how well it goes. And then you make some decisions on that. So those are the first 2 steps that you do with all of it. Go. Now with step 2, it's called describe. So you've identified all the big pieces. And this applies more to clean room than it does to a reverse engineer, but it still applies. With each of the objects, you had all the basic fields, primary key, descriptor fields, date fields, all that jazz, all the usual things you'd find. If you're dealing with a customer record, you'd add a customer name and an address and a phone number. Even though you might not have all that information, there's just certain things you know you need to have, or you should know that you need to have. There's design patterns. You try to identify as many fields and properties as possible. So, for example, we want to describe a customer. You try to identify as many pieces of a customer as you humanly can, right off the bat. And you just list them all out. This is when you're working on a whiteboard. Way better than working on a computer because it's tactile. And then you assign some data types to each of the fields. Why? Because it's a good time to start thinking about what kind of data goes into them. All right, then you create the relationships. So you've roughly identified things, you've roughly described things. Now you want to start connecting relationships between them. You want to start identifying what connects to what. And you sit there with a little marker and you draw lines. And you identify which ones are the parents, which ones are the children. It's a good time to start figuring out who inherits what. You identify which relationships are mandatory. And you create the foreign keys as needed. And here I say, remember the naming conventions. Did the projector just flicker? Great. It's a good thing I'm on slide 11 of 15, eh? So you create the foreign keys as needed. There's naming conventions, usually depending where you work. I did cover naming conventions like day one, but depending on where you work, the naming conventions change. So as long as you remember what naming conventions are, you're good. Step 4, you start normalizing. Last week's lecture. And lab 4, fun times. Lab 3, 4, whatever lab you guys are working on right now. First normal form, no repeating fields, has a primary key, and somehow, for some reason, my copy paste broke and I put it on 2 separate lines. Second normal form, all the data have correlated primary keys must depend on the whole key. Third normal form, all data must rely on the primary key. That's the short line descriptions of the normal forms. You create the reference table as needed, so as you're breaking things out, you create your reference tables. You replace your standard fields in the standard tables with foreign keys as needed. You want to go at least the third normal form. Boy's cod is nice. Third normal form is fixed. They'll cover you 90% of the time. The normalization process sucks, but it's necessary. It's where this is what allows you to avoid duplicating data and causing yourself problems. And then we get to step 5. Okay. Step 5, you review the design for potential issues. So normally what you want to do is you take a little break. Put it down. Go work on something else. Go take a walk. Go walk the dog. Go have a beer or a cup of coffee as applicable. Or a coffee with booze in it, whatever works. It's all good. Go have a break. Then you go back and you look and go, what was I thinking? No, you don't want to try to think what you're thinking. You look at design and go, what the hell was I thinking? Normally that's like the first thing that crosses my mind when I look at a design. So then after you've identified some of these issues, you probably go back to step 1 and you roll through the process a second time. Then you find a peer to review your stuff if you can find a peer. Problem where I work is I have no peers in the database design side of the deal. I'm the only database designer. So I have to make sure I get it right on my own. I have one guy that'll double check, make sure I'm not crazy, but his database designs tend to not be as good as mine. So, you know, he might identify a few issues here and there, but it tends to be the other way around where I fix his a lot. He doesn't have formal database training. That's why. After you identify your weaknesses, start over at step 1. Keep going through the process one by one. Identify any missing gross objects. Add them into the design. Normalize. Review. And when you're doing your review, you want to look to the future. Did you ever hear the expression, don't code yourself into a corner? I don't know if they've taught you guys about don't code yourself into a corner. Okay, how many of you have painted a room? And do you ever paint yourself into a corner? Or even better, painting a deck, staining the deck, and then you realize you're stuck against the wall and the deck's wet. Stupid shit you do when you're young. Been there, done that when I was a teenager. Painting myself into a corner. Had to stand there for 3 hours. The owner of the deck wouldn't let me walk across the wet stain. She threw a bottle of water at me. But I painted myself into a corner. So you think about the future. In other words, you don't want to limit your design to what you need right now because you can guarantee that they're going to come up with something new in the future. But at the same time, you don't want to over-engineer. You don't want to overthink your database because then it gets complicated and it's hard to work with. Okay. Did anybody here remember the Simpsons episode when Homer designed a car? Yeah, okay, at least 1, 2, 3. Yeah, some of us remember that Simpsons episode. That was an awesome car. The kids were in their own bubble. You didn't have to hear the kids. I want that feature. But it was an over-engineered car. It was a mess because it was over-designed. There was just too much in it. It reminds me a bit of cars, the high-end cars from the mid-90s. There were so many features on these cars, they looked like a freaking space shuttle. You got into them. Nowadays, you just have a screen, right? But even that often is overcomplicated. So you don't want to over-engineer, as in, you don't want to think too far ahead either. So you want to try to find a happy medium of, okay, I've planned with synthetic keys, I've allowed enough flexibility to handle more than one phone number, that kind of stuff. But in the future, you don't want to also code yourself in the corner where you only allow one phone number. Some unknown reason you design it so it can only put in one phone number. Or you do something stupid like decide you're going to have a phone numbers table. So each customer can have many phone numbers, n number of phone numbers. How many of you have n number of phone numbers? How many of you have more than 3 phone numbers? Okay. How many of you have 2 phone numbers? How many of you only have 1 phone number? Okay. I guess most of you have cell phones, right? But just saying, right? N phone numbers is dumb. It's just not a good idea. That's called over-engineering. Because you're thinking, we should be able to allow them to have as many phone numbers as they want to. I can admit I was guilty of that because I was planning for the future. And then nobody ever used that feature. So I designed a database that made clunky code because I designed the database in such a way. Don't over-engineer. All right, which leads us to choosing our data types. All right. On Canvas, there's another PDF, as I'm trying to include a companion PDF to every lecture. That is not tied specifically to the lecture. It's like a companion piece to go with it. It explains the different data types you can find out in the wild. So honestly, I shouldn't have to tell you guys what an integer is, because you should know what an integer is. You should know what a date is, because a date is a date. There's a few data types I'll speak about once I'm done the slideshow, so that there's a little more information about them. But realistically, when you review that document, it'll give you most of the information. But when you're choosing your data types for your data, there's a few things you got to think about. How big is the data? How much room do you need for the data? For example, a person's name. How much room do you think you need for a person's name? If you're in North America, you probably want to give yourself, 25, 30 characters for a person's first name at worst, in case they got a compound first name. And you want to give yourself a fair amount of room at the end for the person's last name, especially those coming out of Quebec. You'll have the 12-character last name dash a 12-character last name, 25 characters for the last name alone. You want to give yourself some room. Phone numbers. I love the discussion about phone numbers. How many characters do you need to store for phone numbers, and what data type do you think you should use? This is where somebody actually puts up their hand and says something, or shouts it out. Phone numbers. 10. 10 what? 10 digits. Are we talking a numeric or a character type? Should it be an integer? Can you search for an exchange if you're using an integer? You want to find all the numbers that start with 613. Can you do that with an integer? You can, where phone number is greater than or equal to 613,000,000 and less than 614. Right? You actually have to write this weird query and deal with numbers. Fine. How do you handle international numbers? Hey? Pardon me? Country code, yes. You want to call the UK. What's the country code for the UK? 011. Can you store a zero padded integer? No. Because, therefore, you don't use numbers to store phone numbers. You use a character field. Now, you said 10. Sure. 10 is good if you're only dealing with North America. Are you included formatted or non-formatted phone numbers? Brackets, no brackets. Dashes, or using periods? Are you just using dashes or a combination of dashes and brackets? How are you storing your phone number? What is the business requirement for storing the phone number? These are the kinds of things you think about when you're starting to pick out your data types, right? So as a rule of thumb, a phone number is 14 characters when you're storing phone numbers for North America. Bracket, 3 digits, bracket, that's our first 5. 3 more, that's 8, plus your dash, plus 4 more, that's 13, but sometimes some people like putting a space after the first bracket. 14 digits. Now, did we just cover call in the UK? Nope. Why? Because you need another 4 digits on top of it. Because UK phone numbers are stupid. Australian phone numbers, you need less digits because they have less phone numbers in Australia. They have 1 less number than we do. So when you think about phone numbers, it's a can of worms. So you're better off actually giving yourself, like a 20 character field, so you can handle phone numbers whichever way they need to go in. Okay. How about we're dealing with numbers? We want to store a price. What would we use? Really? And who said integer? Would you want to? Okay, so you'd only sell things for $3, $5. Can't have pennies. Well, we don't have pennies anymore, but you can't have decimal places. So we're going to track our prices down to 23 digits of precision. That's excessive the other way. But yes, that's actually a better choice than an integer, unless you're doing set price, block price. Normally, you do something called a numeric. That's explained in the document. A numeric allows you to have a set length number with a certain number of digits reserved for decimal places. So you do something like a numeric for a price. Therefore, is it a numeric? Is it a number? Okay, a price is a number and it has decimal places. Probably want to use something that supports decimal numbers. Numerics are good for that. They do rounding automatically. We're storing quantity. So we're storing quantities that are of things that can't be subdivided into smaller pieces. Therefore, for that, you'd probably use an integer. 1 box. 1 case. On the other hand, if you're storing weights, you'd probably want decimal places, and then you'd probably use a float for a certain amount of precision. If it's a date, you should probably just include the time along for the ride, just for shits and giggles. It doesn't take up much more room. And I can guarantee at some point in time someone's going to ask you when that happened. And they're not going to be happy saying it happened last Wednesday. Yeah, 6 cases of plutonium went missing. When did they go out the door? Wednesday. When Wednesday? Who knows? Sometime between Tuesday and Thursday. Always, if you're going to include a date, always include the time. It doesn't hurt. It's just safe. Right? So somebody says, we sent out an invoice. When did you send it out? February 1st. Okay. What time did you send it? Because you sent it by email. Oh, I don't know. Let's go look at the date timestamp and see when the invoice was sent. That way you can say, oh, That wasn't done at 10 a.m. while you were on your smoke break. Obviously, you're not the one that sent out the invoice. You got to go track down who actually hit the send button at that point. How big is text? How big is the text? Okay, so suddenly we're dealing with something bigger. A notes field. Some comments. An email, a message of some sort. You got to decide how big the text is going to be. Some database servers don't care. You define something as a text object, or in Microsoft land, a memo. They're the same thing, they're interchangeable. Or in Oracle, it's called a CLOB, C-L-O-B, character large object. They don't care about the size because they have a limit, but the limit is so huge it makes no difference. MySQL, on the other hand, has 4 kinds of text fields. Small text, medium text, large text, and text. Text defaults to medium text. One allows you to put in 256 characters. One allows you to have, I don't remember off the top of my head, 65,000 characters, and the other one allows you a big honking encyclopedia. But it's special that way because it limits, what size of text. Somewhere along the way, somebody at MySQL line decided it was a good idea to have 3 different kinds of text fields. They're the only ones that do that. And then my last line is just say no to blobs. Blobs are a bad thing. What is a blob? Anybody want to take a guess what a blob is? It's a binary large object. A picture, a song, a movie you torrented yesterday. Those are all blobs. When I say no to blobs, I'm saying I've had cases where people said, that'd be such a great idea to store that binary file in our database. Really? Okay. I'm actually replaying a conversation I had about 2 months ago. Really, you want to store the binary data right in the database? Yeah, that's a great idea. It's all contained in one place. Okay. How big are these files? 2. They're not big, 2 to 4 megs each. How many files are there? Well, we're sitting at 75,000 files right now. So 75,000 times 4 megs at the outside. It's not that big. How many files do you plan to have in the future? Lots. Oh, and the users can make copies of the files and store them in their own profile in the database too. Really? Fantastic. Let's go do that. So I did a test database for him. It's set at 36 gigabytes. Then I ran a backup while he stood there in my office. The backup took 22 minutes. That meant that was 22 minutes the system was not available. I said, how often do you want to do backups? Oh, we got to live stream it. Not live stream like video. It's called live streaming when you copy it from one server to the other instantly. Okay, so we're going to keep 2 servers in sync, 75 gigs of data. Okay, good plan. So then, as he was working in the database, I killed the database server. You guys take Linux yet? Kill-9? Did anybody here learn about the kill command yet? Kill's great. You identify a process ID, you type in the word kill, you go -9 the process number. Guess what happens next? Instantly dead. It's basically terminate. I terminated while he was updating his data. Just to make a point. You know what happened to his data? He lost 3,000 files in that one instance. This was test data, so it wasn't real data, right? But he lost 3,000 files in less than half a second. I had to restore from a backup. 2.5 hours later, I then killed -9 his thing right again. I was having fun with him at this point. I was making a point. Don't do blobs. Don't store them in the database. How do you handle blobs properly? You upload the file using your application, your interactive web application. You upload the file. The web server puts it somewhere on the disk, gives it a unique file name, and you store the file name in the database. So we went from a file that is 4 megabytes to something that is 50 bytes. You know how many files you can store how many file names you can store in 4 megabytes as opposed to 50 bytes. You know, how many 50-byte files can you store in 4 megabytes? If somebody wants to do it, they did the math, feel free to give me a number later. But it's insane the number of file names you can store in the same place. So suddenly we went from a 30 gig plus database down to a 35 megabyte database. The files are being backed up using technology that's been around for 30 years. Synchronized file system synchronization. Boop, the files copy from one server to the other. The live replication happens instantly. The backups take about 15 seconds. A restore takes 15 minutes. The restore means I actually took the time to make sure it worked. Say no to blobs. There is one purpose for blobs, and there's only one valid purpose I've found so far. Well, 2 purposes. They're almost the same thing. One is you're trying to store encrypted data, and you're using binary encryption. So instead of being like a text-based encryption where it's all just letters, sometimes some of the encryption actually uses binary characters mixed into the mix, just make things difficult. If you're storing encrypted data, that's fine, because odds are that encrypted data is not going to occupy megabytes. It's going to occupy 50K, 10K. That's nothing. The other place is when you need to store internationalized strings. For example, North American characters, we use the ASCII table. How many letters, how many characters do we need to actually pull out for North American, not including French or Spanish? 26 plus 26 plus 10. Right? That's all we need to store the North American alphabet. How many characters do you think you need to store Chinese? Right? It's a language that keeps adding letters because they don't really have letters. They have symbols. These symbols mean things. Same thing applies to Japanese and Korean. And actually, Korean's a little better behaved than Chinese and Japanese. But those are they call multi-byte characters. So let's say you got a website where it allows the person to type in whatever they want in their own native language. That means that they might be typing in UTF-8, UTF-16, in Latin 1, which is Western countries, in Cyrillic. Insert other language here. And we need to store all these different strings in the database. You'd use a blob field at that point to store that information. Why? Because it allows binary information. So you can take the string and store it in its raw format in that field. You store it in a raw binary, you retrieve it as raw binary. That means there's no data loss, but it's totally unsearchable. You win some, you lose some. So blobs have a purpose. It's for encrypted data and or if you need to store stuff that normally you wouldn't be able to store. But considering most database servers now support things like UTF-8 or UTF-16, which is what they call a character set. If you create a database that's UTF-8, you can shove English with moon runes and everything's happy. It's all good. There's no issues, but blobs are good for encrypted data. All right. Test data is last. When you're doing physical design, because testing is important. Would anybody here want to get into a car that has never been tested? They built a car and they gave you the keys. They go, did you ever crash test it? No. Has it ever been turned on? No. I'm sure it's going to work. Right. Testing is important. One of the advantages of having test data is it gives developers something to work with. So you design this fantastic database. And it's an empty shell, and you give it to developers. Boom, guys, there you go. Being once at the receiving end of one of those, I can tell you, they're not going to be happy with you. They have nothing to test their queries against. They got nothing to test their UI with. They got nothing to work with. Therefore, it gives them, the developers, something that looks real. Load testing. Do you think querying 100 rows versus querying 10 million rows, think the performance is going to be the same? When you hit the 10 million rows, sometimes that's when you discover that, you know, their queries are a little slow. Maybe you need to create some indexes. Maybe you should redesign some of your data because there's a lot of data in the database. So there once was a time generating test data was a horrible process. There was no real way to generate it. There was a few companies that offered a service. They'd create data for you, and they charged your eye teeth for it. Like, I kid you not. I remember when I first started working where I am now, there was no easy way to generate test data. We actually paid $7,500 for test data that matched our database structure. So we sent out an ERD of our database to this company. They created data and they sent it back to us. That was actually a business. And they made a killing because I know they had these scripts that did this stuff automatically. They just had to define the parameters and boop, out came data. $7,500 later. Or you used automatic code generators, or you could go buy, IBM had a product and it would cost you about $7,000, but you could keep using it forever. And it generated test data for you. I don't remember what the product was called because it's dead and gone. But they had a product. There's a few others that had it, but there was expensive software. So now, something has happened. Somebody said, this is a stupid thing. Why should I pay someone else to generate data for myself? And one of the first ones to come up with it was the fella at generatedata.com. The cool part is his product is open source. You go to his website, you can use his website to generate 100 rows of data multiple times, but you're only allowed to do 100 in one block. But you can just go download it to your local machine or to your server, as long as it's a PHP server and it has MySQL running on it. 10 minutes of work later, you have your own generated site where you can generate 10,000 rows of data to go at no extra cost. Generate data has tons of different localized data types. In other words, you can say, I want Canadian provinces, or you want UK phone numbers. You want to have localized names, so you're going to pick all South American countries, and it'll pull out names that sound mostly Hispanic, just so the data feels real. Mockaroo is not a free product, but they've got some options that the other two guys don't have. You can create fake medical data, including diagnostic codes. You can create all kinds of really esoteric types of data. For example, generatedata.com, when you talk about person type data, I think it's got about 8 kinds of data you can generate, phone number, address, that kind of stuff. Mockaroo's got like 18 or 20 different things you can generate to identify a person. It'll do SIN numbers, SSN numbers, it'll do fake email addresses, it'll do all kinds of stuff. And then there's the last one down here, freedatagenerator.com. Less option than the first one, a lot less options than this one, but it supports parent-child creation. So let's just say you have 2 tables. One is a customer and one is orders. You can actually have it create the customer table. Right afterwards, you can create the orders table, and you can say, oh, grab the value for this column comes from this column in this other table. And you say, I want it to generate 1 to 3 rows of data for each parent table. And it just does it for you. Suddenly you end up with these SQL statements that you can just insert, and in goes your data. I'll be doing a short demo of this in a few moments. But yes, this is basically what these things do. I'm going to, like I said, I'm going to go demo the bottom one. That's what I'm going to go do in a moment. And then I'm going to do an onboard design moment. Okay. Please excuse me for a second. I'll be a bad person. My son just texted me, asked me if I needed a ride home. No, I'm in the middle of a lecture. Okay, now I want to go to okay. Free data generator looks like this. It's not a pretty site. Right now, he only supports one country, so it has limits. But he does support multiple database systems, which is a nice feature set. He supports MySQL, Oracle, Postgres, and Microsoft SQL Server. In other words, he's covering the big four. So what I'm going to do is I'm going to generate a little bit of data just to show you guys how it works. So I got my table down here. So I'm going to give it a new name. I'm going to call it customers. Okay, I'm going to do 100 rows. And I'm going to add some columns. So I'm going to call this one ID. And it's going to be a numeric identifier. And then I'm going to add a name. That's not how you spell name. And we have a few things in here. We've got people, full name, like this. And we want to do capitalized, first name, last name. Now we're going to add their SSN. Since, I can generate fake social security numbers. And we can add, hey, look at that, we're going to generate some fake credit card numbers. We're going to generate all of them. All right. So I've got 4 columns. So I'm going to add a child table so that you can see what it does when it generates the whole thing. So it's going to generate all the data at once. So I'm going to call this receipts. Parent table is customers. And I want to generate from 1 to 5, 6 receipts. So I got another one here. Shows it's a child. So I'm going to add a column. I'm going to add my ID column, which is, again, numeric identifier. And I'm going to add the, what did I call the first one? Customer? Customer ID. And it's from the parent table. It's coming from the ID. And then I'm going to go, I don't know. I'm going to call it product. And there's something in here for commerce. Product name. Capitalized. Save and close. All right, so it's going to generate 100 rows of this and 1 to 6 rows of that. So if I do generate data, give it a minute, and Notepad++ popped open over here. All right, so this is what it did for me. It created a customer. Right at the top, you can see there it is with a SIN number and a fake credit card number. It looks like real data. Then right here you can see that there's receipts, and you can see that it created the auto-incrementing key down that side. The customer ID matches the parents. It has a product name and various things. Actually, this guy's pretty good because he's got tons of data in there. This would look completely real as far as that kind of stuff works. It does have some limitations. This one only allows a table to have one parent. So if you're dealing with something like order lines where you have an order as a parent and a product as a parent, it's going to have a limit. Why? Because this site doesn't allow it. But at least it covers, basic table structures. So if I had a database structure designed like this, I could take this, run it against it, and populate my database. This is an example of one of these tools. The other two behave similarly. I would recommend as a student, as someone that's planning to do development that involves databases, to go experiment with some of these apps. Why? So you're ready for later. And by the way, you'll need this for Lab 5. So, feel free to refer to this video if you weren't paying attention. I'm really impressed about how little there is going on in my classes. It's great. So that's an example of data generation. It's not much more complicated than that. Obviously, if you're working with a more complex table structure, it's going to get a little more difficult. And things like and websites like generatedata.com doesn't support the parent-child. So how would you handle generating parent-child type structures with a website like generatedata.com? What you'd use something called a number range. So you create your parent table, customers, generate say 10,000 rows of customers, boom. Then you want to create the orders, and you want to say, well, it doesn't support creating the parent-child relationship, so how am I supposed to handle that? Well, we know we have 10,000 customers, and it goes from 1 to 10,000. So you could set the foreign key to be a numeric range of anywhere between 1 and 10,000, and it just randomly generates it. So a customer may have N, one guy could have 15 orders, and one guy have no orders, which actually is more realistic anyways. So that's how you do it with generatedata.com. You use a number range, a numeric range. So it's, it just randomly picks a number between min and max. It's just like ordering on Amazon. You never order just one thing. Well, especially when you start ordering from Amazon. Then you get Prime. Then you got to justify having Prime. So you keep ordering stuff. You never have just one order, so therefore when you generate lots of data, that works. Okay. That covers the slideshow / screen time. Next step is I'm going to do it on the board design. And now I'm going to turn on some lights and put away the screen. Oh, apparently you hold it down. I have the whiteboard. All right, now I got to figure out my camera position. Okay. I'm trying to pick my whiteboard. It's pretty hard when you're trying to, there we go. This is going to be cute on the video. You're going to just see my hand appearing in the corner. So I'm trying to figure out my borders. All right, I got from here to here. So it's all in frame. I should really get a longer course. I can put the camera right there and move it back a couple of feet. But anyways. Great. Oh, no erasers. Okay, so I'm going to do what I call it's a white room implementation on board design. So what are we going to do with it? We're going to go with, I'm going to pick a topic, and what happens is people start communicating towards me what should be in this. And if you remember the design process, you identify the gross objects first, and then you start filling in the details. Anybody here write stories creatively? Anybody here a creative writer? One? And depending on, normally when you write, if you want to write good stories, you write an outline first. So you have no open plot points. Right? Yeah. So there's ways of doing it. And, often people create an outline of the story first, and then they start filling in the chapters. Those of us that have managed to get stories published, have suffered through it. Essentially, we want to do the same thing. We're going to identify the gross objects. And normally, and actually the mix in here is good enough for this, we're going to go with a pet adoption agency. Yeah, that one's she's nodding her head because I've been through this before. You knew it was going to be that, didn't you? Okay, pet adoption agency. This one, every time I do this, it's different. Every single group of students is different. And so far, there's one key piece of information that every group forgets except for once. The guys last term got it on the first try. First time ever. And I've been doing this example for 7 years. 2 terms a year for 7 years. And one group got it on the first try. Let's see if you guys are group number 2. Let's do it, right? And you guys have an unfair advantage because there's at least 3 people in here that I recognize that used to be in CET that moved to the program. that have been through this, so there's a chance they're going to save you. Okay. Pet adoption agency. So essentially, picture something like the SPCA or a shelter of some sort, a chain of shelters. And essentially, their purpose in life is people bring animals to them, and then they put them up for adoption after they've been checked out, and people adopt them. That's the vision quest. Now we start filling out bits and pieces. So what are the gross objects? There we go. Believe it or not, that's the one they always forget. You're laughing. I shit you not. People forget about the poor pets. I'm going to write everything in uppercase because my handwriting sucks. Normally I do everything in lowercase. Okay, what are some of the other gross objects? That might be, yeah. Sure, that's a new one. That's the first time I've ever had somebody say that. Okay. Okay. Now we're going to play the semantics game. Should be people or persons. Could be a customer. Are we tracking who drops off the animal? Are we exactly? Are we? Maybe we should. I've dropped off animals at these SPCA a few times. Cats seem to love my garage. I have cats of my own, so I can't keep throwing cats into the house. It's just not cool. Then you become a crazy cat person, and that's not good. As much as you love cats, it's not good to have more than 3, because it gets kind of weird when you're outnumbered that much. So we want to track people, right? Some of them could be customers, some of them could be drop-offs. And there's been a case where I dropped off a cat because it walked in my front door. No tags, and went to bed on my bed. And my cats are like, right? They're going, who the f is this in this house, right? My cats are losing their shit. And this cat's sleeping like a proud little queen on my bed. Yeah, exactly. So what I ended up doing is I took that cat, dropped it off, and in case it was microchipped or it was owned and somebody lost their cat, right? I didn't want to adopt somebody else's cat. And I said, if nobody adopts this cat in 2 weeks, give me a call. My mother-in-law is looking for a cat. And 2 weeks later, they gave me a call, and by then the cat wasn't fixed. She was fixed. She was microchipped, and it cost me a dime. Then I paid the $100 adoption fee. Whew, off to Pembroke the cat went. But, there's people that drop off the cats, and there's people that adopt the cats. So we're dealing with people or persons. And people argue about the people versus persons terminology, right? Because they're both valid. If you have several individuals in a room, there are people in the room. However, they are persons. They're individual persons. So you can use either argument. Persons works better grammatic for this, so we're going to go with persons. Like such. Okay, so we've identified 3 gross objects. What other gross objects should we identify? Yes? Sure. We're going to put volunteers same thing as employees at this point. Trying to keep it simple. Yes? That's the other one I was waiting for. Locations. Because I said, there's multiple branches. The SPCA has one head office, but they still, which is kind of weird. The SPCA is in Ottawa, but all the pet stores are carrying the animals from Gatineau. Did you ever notice? You go to PetSmart and they got the cats for adoption, and it'll say, the Gatineau SPCA, but not the Ottawa SPCA. Because the SPCA in Ontario is not allowed to put their pets in pet stores. But they might have multiple branches. Okay. Yeah, No, I got no problems with that. I'm just trying to find the right spot on the board to put it. I'm just going to call it medical. But I'm putting in a star next to it because it's going to get changed into something else later. All right. For now, I'd say you guys grabbed all the big pieces. All the big pieces we need. I don't want to be at this for 2 hours. I just want to get the basic process done. So we identified all the gross pieces. So we're going to start filling in some of the details. And if you remember a little further back in today's lecture, how do I feel about natural keys as opposed to synthetic keys? Yeah, use synthetic keys, right? So realistically, now the next step is you start filling in some of the basic details. Well, in here, like one of the basic details you should have is primary keys for everything. Since I say you should use synthetic keys because they're better that way. And I created a primary key called ID, and I called it that everywhere. Why is it called ID everywhere instead of like in medical ID or employee ID? Is because when the frameworks that have de facto the naming conventions have decided that primary keys should be called ID. Why? You don't need to guess what it is. Because if you use, for example, person ID, great. Then you got a foreign key somewhere else that says person ID. Which person ID are you referring to? This one or that one? You don't know. It gets a little more complicated. You end up having to use all kinds of table prefixes. Then you have persons.person ID. You're making things longer than they need to be as opposed to persons.id. ID from person. But if the foreign key is called person_ID, then you know it's the ID of the person from the persons table. The naming convention allows you to understand the structure of the database without a diagram. Okay. Now, the next thing we should probably throw on there is a descriptor of some sort. But instead of going that way, I'm going to actually start identifying some of the details on a table-by-table basis. Let's talk about persons. What are some of the particulars, the details of a person? Name. Okay. What did you say? Yes. Yeah, but they could be an adopter and a dropper. So it's a one of three possible state. Yes. Status. Yeah, that goes slightly separate. We're going to go with status, and we're going to throw in type, phone number. What else? Address. Now I'm going to use the curly formatting here. Curly's, if you remember right, means compound value. Because I don't have that much whiteboard space. So when you see somebody write something on a whiteboard, they're describing a database, and they use something like this, you should assume that you want to explode it to its component pieces. And what's an address made out of? Address 1, address 2, city, state or province, postal code, maybe a country. So this identifies actually 6 fields. But we only have room, right? All right, so we got the basic types here. Employees. Okay. Name. What else? Sure, let's get into HR. Okay. We're really going down the HR rabbit tree. Yeah, exactly. There's things, right? I'm leaving it there with a star for now because I want to have a little conversation about it later. Okay? All right, well, let's pretend we got enough about the employee. We do. All right, equipment. Okay, we got type. And maybe a name or a description of some sort. Sure, we're going to go with quantity. Ah, now we got locations down here. Hey? Yes. Okay. Locations. We're going to always add a name on that just for shits and giggles. And then an address, and I'll do the curly thing again. See if I can draw that curly a little better. Yeah, it depends on how you want to associate how the people are connected to each location, right? Yes. Sure. Put down a phone number. Yeah, and a contact name. Let's go with that. Okay. We'll pretend we have enough for that. Okay. Now, we're going to talk about pets. What we're here to talk. Start describing our pets. There, go, thank God, name. Would you believe I've had cases where I actually had set for almost 5 minutes waiting for someone to come up with a name for an animal? Yeah, okay. This is where things get complicated. Okay. For now, we're going to put down drop-off date here. What else do we worry about pets? Okay, sure, we'll put down location. Age. Health falls under medical, right? Sort of, but not quite. Right. Who dropped it off? But then that's sort of a history kind of thing, right? Same thing with the medical. Sort of a historical thing. Maybe medical shouldn't be medical. Maybe it should be a history. So suddenly you got some magic. Oh, they don't have any. No whiteboard erasers, eh? I'm going to rename it to history. That's why I put a star next to it earlier. You know, for a brand new black marker, it's not writing too good. History. The history has an ID. Man, I didn't give myself a lot of room for that table. All right. I'm going to put in entry timestamp. Why? You should know when the entry was created. Are we going to put in a type of entry? That could be medical, a note, a point in time, something. And then we're going to have a note. Note of some sort. And probably, we'll probably need a few more things attached to this, right? Probably need a person and an employee. I usually give myself more room for history than that. Yeah. That'd be kind of important, eh? Pet. Or animal, or what do you want to call it. All right. Pardon me? Yeah, I know. Actually, I'm probably going to shove it. Yeah. See, I should have gone a little further that way. That was nice, eh? Type. Notes. Person. An employee. Okay. Anything else? Man, that green marker doesn't erase at all, does it? What else do we need to know about pets? We're missing a few things we could throw in there for fun. That'd probably be part of the history, right? No, we're talking about the pet itself. What else? Sure. We're going to go with weight. Size. Size is iffy because it's depending what kind of animal it is. The measurement's a little hard. What else? Hey? There we go. Color. That's the other one you never hear. Temperament. That gets iffy, right? So at this point, you'd probably just put that as part of the description. So you probably just won't have a description field. You have a description there, you could say, you know, it's a friendly cat, loves dogs, hates other cats, will eat your child. After shredding it to pieces. Hey? Because the temperament. I had a cat that used to slap my daughter every time she walked by. Until she was able to open the door for him. And then she became his friend. Because she cried all the time. She screamed all the time. She was a screamer and a crier, right? Walking up and down the hall screaming. The cat would sit there and just go whack every time she walked by. It was hilarious. No claws. He'd just slap her on the ass every time she walked by. That cat was great. So, we got all the bits and pieces here. No, you laugh. I kid you not. It's the truth. I even got video of it at home. All right. So, we got a fair amount of information here. What we got to start identifying now is some of this stuff is multi-valued, and some of it is really it should be a list. So I'm going to start underlining things that really should be lists. For example, a status. There could be more than one status, right? What type of person is it? Depending on it, there could be three types? Drop-off, adopter, drop-off and adopter, deadbeat, you know, puppy mill, didn't bother to get their cats ever fixed. Okay, so these are the things that can be done. Same thing down here, we can look at position, type. Seeing a pattern there with the word type? Yep. Breed, species, gender, color, not really, because it's really people really argue about the color thing. Is the cat cinnamon or is it orange? I don't know. It's a cat. It doesn't care. Gender. Now, why would gender be a list? Because animals have 4 genders. Unlike humans that have like 50, cats have 4 genders. Male, female, spayed and neutered. Believe it or not, those are actually treated as separate sexes. A cat that has had his nuts cut off is known as a neutered cat. A female cat that has his little bits pulled out is known as a spayed cat, not a female, even though we treat them as a female, but they're known as a spayed, as far as the animal industry is concerned. So animals have 4 sexes. We should never assume their gender, but they have 4 different genders. So it's a list. Because eventually somebody will come up with a new gender. Breeds and species, same thing there. The rest of these, we're going to leave them alone. Drop-off date, not important because we can actually grab it from the history. So we can get rid of this field. Okay, so for now I identified the things that should be lists. Wow, this border really sucks. We identified things that should be lists. And I'm going to create a couple of these, but I'm not going to do them all because it's just going to take forever. You could. Let's put in location here. Okay, we got location. So I'm going to take the status table here, for example. I'm going to create a table called person statuses. And we always add our primary key, like such. And then we can give it a name. And now what we do is we take our foreign key here, we rename the table. I need a new color. What's it going to be? Purple. I'm going to call this status ID. Like such. And now we have a status ID that points to a person status. Now we can do the same thing with type. Put in our ID. And then put in our name. And then we put in our person type ID. This actually should be person status ID. Like that. And theoretically, we should be doing this for everything that's underlined. For now, I'm going to skip that. But I am going to finish some of the other foreign keys. Specifically, I'm going to deal with person ID, employee ID, location ID, equipment had a location ID because we spoke about that earlier. I did this one backwards. Like that. And this one has a location ID. Now, we have a pet ID. And we should have a type table, but obviously I'm running out of whiteboard here. So we have this. Gender would obviously get its own table, genders. This would become gender ID. The one I want to bring attention to is breed and species. Theoretically, you don't need both in a pet. Can somebody tell me why? Anybody want to take a guess why you don't need both on the pet? Which one do you actually need on the pet? You sure? The breed. You have a calico cat. You don't have a calico dog. It'd be cute, but it's not. They don't exist. You can't have an angelfish cat. You can have a catfish, but not an angelfish cat. So you don't need species in here. What you need is breed. I'm going to put in breed ID. And I'm going to create two more tables. Okay, we have species and breeds. And as always, put in our primary keys. Put in our names. So a given breed can only ever belong to one species. So therefore, what we end up doing is we create something here called species ID. That's one of these jobs. And then we can actually go breed to here. So as part of the input form, you pick the species, pick the breed. But all you ever need to do is store the breed, because you'll know what the species is because you can climb up the tree. So you go, oh, it's a Himalayan. Himalayan is here. We grab the species ID from here, doing a join. So then we know it's a cat because it's joined through the species, the breed. The breed tells us what the species is. Part of the design process is avoiding duplicated data. This avoids duplicated data. If this was a really complicated structure, then you'd need it, but it doesn't need to be complicated. Same thing like I said earlier, gender, you'd create your own table. Equipment types, you create your own table. Address needs to be broken out to its component pieces. But these are all the bits and pieces basically put of a pet adoption agency broken down into its component bits and pieces. I'm going to do a quick little bit of, I got 5 minutes. So, for example, just to assign some data types really quick. ID is probably an integer. Why? Because it's synthetic. A name. You probably want to use a varchar. Probably 50. Why? Because some people give their animals really ridiculous names. Sir Fluffybutt the Third, son of Gunther. Yeah, give the cat a shorter name. Or like you call one of our cats, Bro. Why? Because that's just who he is. That's his personality. His name matches it. Now this, hey? Yeah, just call it cat. So the breed would be an integer because the primary key is an integer. Foreign keys match the same data type as the parent key. Location, actually, location ID should be going to here also. Gender, ditto. Age. Either it's going to be a whole number or we're going to allow partial numbers. So we probably want to allow a numeric. So we can allow like a half a year or a quarter year. Because most of the time when pets are an adoption agency, they don't know when the animal was born, really. May 2000. Okay, we don't have an exact age, so we'd go with a decimal place. Yes. So age, you'd probably want to use a numeric. All right, you'll see that I wrote down numeric 3, 1. Numerics are special number types. What this saying is it's going to allow a 3-digit number, one of which is reserved for decimal places. So that means I can store 99.9. Except for some species of parrots and turtles, that will cover pretty much every animal on Earth. And if you're dropping off a 99-year-old parrot for adoption, you suck. Just give it to the kids, give it to a neighbor. God, that thing doesn't need to go through that process. Weight. Normally measured in grams or ounces. So those would be whole numbers. Size. Who the hell knows? Are we measuring length? Are we measuring at the shoulder? Are we measuring the circumference of the angelfish? Oh yeah, we'll break out the ruler. 12 by 14 by 6. It's a box. You like that, eh? No, realistically, odds are you're going to use a freeform field. Why? Because different animals are measured differently. Birds are, size. It's a lovebird. It's that big. They're little, volume of lovebirds. Now, you can hear my lovebirds at the park. They're stupid. I'd say just use a text field. Like even a varchar 50, that'd probably cover enough. Big. It's a St. Bernard. What size is it? Huge. Description, drool. Color. Color, there's always a fight usually with the students over the color. Some people say, oh, it should be a drop down. Really? Sure, you could have a drop down with like every color under the rainbow. It's a green cat. No. RGB color. But hey, what happens with a calico? There's 4 colors there, dude. Exactly, the alpha blend. But just saying, there's limits of what you can do. So the color, again, you'll want to use a varchar field. And the description, you'd probably use a text field because you want lots of room to describe this animal properly so people can adopt the right animal for them. That's quickly how you determine your data types. I do want to speak quickly. I described the numeric. I do want to speak quickly about varchar versus car. You've probably noticed there's the 2 times the text fields, right? There's car and varchar. See, I'm trying to catch all the stuff I didn't do last week. So that's why the lecture's going right to the last minute today. Then there's varchar. Okay. The difference is char is fixed length. Varchar is variable length. If you define something as a char 6, for example, character 6, that means it will hold 6 characters. However, if you only put in 1 character, it still occupies 6 characters worth of space. So that means no matter what, it always occupies 6 bytes. So that means if you put in the letter A, what it'll actually store is it'll go space, 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 A. Used to be chars were faster than varchars. Nowadays, there's no difference. The computers are so fast that a lot of database servers, they say don't even use these anymore. Like Postgres, they say don't use these. There's no performance gain to this. But Oracle, there's a performance gain. Go figure, Oracle's got to do things a little different, right? And then there's varchar. So if I do a varchar 6, what varchar does, it stores the number of bytes plus 1. So again, I want to store the letter A. What does the varchar store? Varchar will put in A, and then I'm going to put a little star here because I really can't draw binary characters. It'll do A plus something. It's like a marker. It identifies that the field ends here. So the character uses up 6 bytes. The varchar will use 2 bytes. I don't know what letter that was. 2 bytes. The only problem with varchar is if you hit all 6, A, and an A. And then it still has this. So if you actually use the maximum length of a varchar field, it'll hold 7 bytes as opposed to the 2 bytes. Now, it's rare to fill out all 7 bytes. Why? Well, in this case, it wouldn't be rare, but if you're using like a varchar 50, if you used a char 50, you'd be using 50 bytes every single time. If you're using a varchar, you could be using 2 to 51. Most of the time, it'd be less than 50, so you're actually doing a net gain on space. Now, if you guys think, oh, well, you're just talking about how big these hard drives are. Sure. But when you're suddenly dealing with 30 million rows of data, 50 million rows of data, although that sounds like an absurd number, but we have a table at work that just hit 36 million last week because of Joe Bob Hacker, but, you know, it hit 36 million. That table occupies 250 megabytes by itself. How much of that is text? A lot of it, because it's a log table. So it's logging IP addresses, it's logging message digests, it's logging all this stuff. So it occupies tons of room. But it uses varchar fields, so some of these digests are smaller than others, so it occupies less room. If you're storing something like a postal code, knock yourself out and use a char field. Why? Because you know it's 6 characters long. It's never more than 6 unless you're in the States. Because Americans were dumb and they planned poorly. The American zip codes aren't, remember they used to be 5 digits, right? They're not 5 digits anymore. Because they ran out of postal codes. Now they got routing numbers. So instead of being 90210, it's 90210-14563. Because they ran out. So somebody said, oh, we're getting clever, we'll just add more numbers to the end and a dash. So for postal codes and stuff, you'll use a char. For names, you'd use a varchar. Why? Because the odds of somebody filling out the whole name field, unless you're Hispanic, are small. I keep picking on Hispanics because they're horrible names, but, you know, that's fine. Don't feel bad. I pick on all nationalities equally. So postal codes and stuff, characters are good. Names, you want to use a varchar. Why? Because in general, they use up less room unless you max it out. Then it uses 1 more than the char would, but the odds of hitting that outer limit, pretty small. And that's it. I hit all my dots in my eyes and all that jazz.